So Parmesh, welcome to YourPedia, and let's start your
Thank you.
computer organization architecture snap,
Okay.
right?
Okay, sir.
Okay. Can you tell me what are the three components of a system bus?
Sir?
System bus.
Yeah, address bus, data bus, and control buses.
Okay. And can you explain what is isolated IO?
IO mapped IO, sir.
Yes, isolated IO. Yes, you can say IO mapped.
Yeah, IO mapped IO. For the CPU as well as to the memory and IO devices, the common three shared buses will be there. Okay, in case of IO mapped IO, because of this, there will be no different instructions for memory as well as IO. The
Yes.
instructions which are for memory, the IO can also be accessed. Okay.
Okay.
And also and one more the difference was 1 minute, sir. Yeah, there will be more number of instructions to the IO and more number of addresses to the IO, as well as IO device will be more. These are the differences. These are isolated IO map.
Okay. Can you explain what is memory mapped?
Yeah, memory map nothing but in this from to the CPU as well as to the memory and IO, only data bus and address bus will be the common. Okay, and the control bus will be separate. Okay,
Right.
for this the memory as well as the IO, the separate instructions will be there. Different instructions will be there, and also here the less number of addressing modes will be there. Less number of instructions will be there, and the input devices also very less number.
Okay. Let's say that you have a 32-bit CPU.
Okay.
And 256 KB memory.
Okay.
It is a memory mapped IO.
Memory map. Okay.
And 3 bits, when the first 3 bits, the most significant bits will be 0, then
Okay.
the addresses will be referred to the IO part. So how many memory addresses will be there?
The 256 is KB, right?
Yes.
The cache.
Yes. KB.
250 is cache. Okay.
The KB is the main memory.
This is 256 KB is the main memory. Okay. The instruction is 32-bit, right?
Sorry?
Instruction is 32-bit.
32-bit CPU it is.
Okay.
So if the first 3 bits are 0, then it will be mapped to IO. So how many memory addresses will be there?
Only 3 bits will be, so the remaining 29 bits will map it to the memory, sir.
That you have to see.
Sir?
That you have to figure out.
Okay.
I'm saying that when the first 3 bits are 0, then it will be mapped to IO. Otherwise, it will be mapped to main memory. How many these memory instructions or memory addresses will be there?
Over 1 minute.
Yeah, take your time. No issue.
So 2 power 18, sir. 2 power 18, the memory addresses will be there.
2 power 18. Okay. Okay. Can you explain what expand opcode technique is?
Sir?
Expand opcode technique.
Opcode technique, nothing but in instruction.
Expand opcode, yes.
Sir, opcode, nothing but the operation which we are performing on operands.
What is expand opcode technique?
Expand, sorry, sir, no idea. Expand opcode technique.
Okay.
Can you give some hints, sir?
Basically, when you convert the let's say that you have been given there are number of 1 address instructions.
Yeah. That okay. Sure. Okay, then I'll explain.
And how many 2 address instructions are?
Yeah, possible? Understood. Yeah, understood. For example, if we have 2 addressing modes as well as a 1 address addressing mode in the same CPU, then we will see how many instructions for two addressing mode. In that, how many are used? Okay. So total minus if we used, then we'll get the unused instructions. Okay. In that,
okay, let's say that you have 2 address instructions.
Okay,
2
tell me,
types
sir.
of 2 address instructions.
Tell me, sir.
And
many?
one has a register reference and one memory reference.
Okay.
The other one has two register references.
You're saying only two register addressing as well as one register address, right?
These are two address instructions.
Okay.
There are two different two address instructions.
Okay. Register and memory.
One type of instruction will have one register reference and one
Okay.
memory reference. The other will have two register references.
Okay.
So which one will you dilute to get the other one?
Sir, irrespective of the register memory, we'll check the opcode. Okay, how many instructions for opcode? Okay, the addressing mode which have the less opcode bits, that will take it.
That's what I wanted to hear.
That will take it. Okay.
The last time you said when I asked you the original question, you said that the one which will have you will dissolve the two address instruction to one address. So it doesn't work out that way always.
We'll take it.
Size of opcode,
Yeah.
yes. If the opcode is smaller, you will choose that one. Yes.
You will choose that one. Yes, sir.
Yes. Okay. So let's say that you have 84 instructions.
84 instructions. Okay.
So you will get the opcode, right? Opcode bits.
Yeah, I'll get it. Should I say?
So two register references are there.
Two register references. Okay.
And each register reference have 36 registers.
Okay, 36. What? Okay, fine.
And two register references, right?
Two register references. I mean, two addressing.
Yes.
Yeah, fine.
So and
each
memory
register
reference,
have
one memory reference of 256 KB.
256 KB. Okay.
And 13-bit immediate addressing fields or bits.
13 bit.
13 bits for the immediate addressing.
Immediate addressing. Okay.
So let's say that you have 100 instructions. You have to store 100 instructions of this type.
Okay.
So how many bytes of memory will be required?
Okay, 100 instructions. You have to. So how many bytes of memory?
First, you have to find the size of one instruction.
And we have to multiply into 100.
To find how many will it require to save 100. Can you do that?
Fine, sir. Yeah, I'll do. Give me 1 minute time, sir. Sir, 2 power 50 into 100. The each instruction size is 50 bits.
Each instruction size is 50 bits.
50 bits. And multiplications are 100. We have to multiply with 100 instructions. So 50 bits each instruction.
So 50.
So 2 port, like each instruction bit is 50 bits. Okay.
So you have to store the instructions only.
Okay. So I mean, like in the instruction, okay, 2 power 50 bits. So 2 power 50 into 100.
Why you are doing 2 power 50? I don't get it.
With 50 bits, we can able to address the single instruction, right? You
have to store the instructions, as simple as that. Just instructions you have to store.
I'm not getting.
Like when you have an instruction, let's say add R1, R2.
Yeah.
And it's a 4-byte instruction. So when you store it, it will take how many bytes? 4 bytes.
Okay.
So that's how you have to store 50 instructions.
50.
Size of each instruction is
50.
So you have to store 100 instructions. And size of each instruction is 50 bytes. 50 bits.
50 bits.
So how many? How much space?
How many bytes?
How many space? How much space? Like in bytes or bits? You
okay.
You can answer in bits as well. No issue.
Nothing but 5,000 bits.
Okay, that's a little. There is a little error in this. So we'll address that later. Okay.
Okay.
Let's say that I have given you an instruction, add, write it down, add
Add
M. M is a memory
M.
reference.
Yeah.
At the rate R1.
Okay.
मतलब after M there is a add comma M comma at the rate R1.
Okay.
Comma R2 in brackets there is 4.
What this for? Nothing but whether it is address or whether it is opcode.
Kind of index addressing mode, you know.
Fine. Okay. So it was located into the index.
There are let's say we know that there are 5 parts to the instruction cycle. Information fetch,
Okay.
information decode, operand fetch.
Okay.
Operand fetch, there are 2 operands here, R1 and R2.
Okay.
Then there will be ALU operation. Then there will be write back.
Okay.
So the instruction is of 4 words.
Okay.
So tell me what will be the in each part of this instruction cycle, what will be the number of memory references and register references and ALU operations to perform this instruction?
In each stage.
Yes. I have mentioned you the 5 stages. You have to fill.
Yeah, instruction fetch, instruction decode, operation fetch, and execution and write back.
Yes, instruction fetch, instruction decode, operand fetch, and ALU.
Operation
and
fetch, execution. Yeah, execution and write back.
Yes.
Okay, and we have to. Sir, we are having 2 memory access. Okay, initially while fetching, will access the memory for initial instruction. Okay, and while decoding, we'll decode the what the instruction we have, and we in the first one you mentioned that add MR1. Okay,
no.
M is nothing but
in instruction fetch, how many memory references will be there? I am asking that.
Only one.
Okay, in instruction decode.
Instruction decode, like no, like it won't already the instruction which we are fetching. That one only we will decode. We won't be any memory.
When you are
memory
decoding
access.
the instruction, there must be some memory references there.
This memory is there. Add MR1. M memory is there.
Okay. Again.
Okay. Then after we'll operate the fetch. For operating fetch, we again will. So the operand will be in the memory. And one more thing, R1. R1 will be in the register. We want to go to memory for operand fetching. Okay. Then in the execution, we'll execute and we'll write it back to memory.
Okay. Let me give you your feedback, Pramesh. तो पहले आपसे मैंने सिस्टम बस पूछा, उसके बाद मेमोरी मैप्ड, यू आंसर्ड इट करेक्टली. उसके बाद देखो जैसे बिट्स वाला जो क्वेश्चन था, वो क्वेश्चन क्या था कि आपके पास 256 KB मेमोरी है और 32 बिट सीपीयू है. तो 32 बिट सीपीयू का मतलब है 32 उसका वर्ड साइज है.
yes sir, it will take input as 32
एड्रेस जो बट एड्रेस पिन्स जो हैं वो 256 KB से डिफाइन होंगी. सो एड्रेस पिन्स विल बी 18.
यस सर.
सो अगर 18 पिन्स हैं, उसमें से पहली 3 को जब मैं 0 कर देता हूं तब वो क्या देता है मेरे को? आईओ.
Yeah, remaining 15 bits for IO,
right? So when the first 3 bits are 0, all the other bits will have anything in the can have anything in them. So
yeah,
those addresses will be 2 raised to power 15. So the IO addresses are 2 raised to power 15. So memory mapped will be 2 raised to power 18 minus 2 raised to power 15. That will be the correct answer. So total minus whatever you have associated with the IO part.
IO part, you said only 3 bits, right?
When first 3 bits will be 0, you cannot say you can if I am
okay, that we have to exclude it.
So when the first 3 bits are 0, there will be 2 raised to power 15 addresses.
Yeah, correct.
Because first 3 bits are already you have assigned zeros.
Okay, okay.
That will be the IO part. So if 2 raised to power 15 are present in IO, then the memory will have 2 raised to power 18 total minus the IO part, which is 2 raised to power 15.
To 15. Okay, okay.
Okay, after that expand opcode you have mentioned, you have explained correctly. उसके बाद मुझे थोड़ा ये 84 इंस्ट्रक्शन वाले क्वेश्चन में काफी इश्यूज थे कि पहली बार 2 raised to power 50 क्यों करना है? जस्ट हमने स्टोर करना है इंस्ट्रक्शन को, तो इंस्ट्रक्शन स्टोर करने में तो उसका साइज लगेगा. अब इसमें एक और चीज का ध्यान रखना होता है, 50 बिट्स का इंस्ट्रक्शन है, ठीक है?
Yes, yes, sir.
अब 2 इंस्ट्रक्शंस ओवरलैप नहीं कर सकते हैं कभी भी.
Yeah.
ऐसा नहीं है कि आपने 1 बाइट मेमोरी में आधा वो स्टोर कर दिया, आधा वो स्टोर कर दिया.
Okay.
ठीक है. सो फर्स्ट यू हैव टू स्टोर द
This 50 bits.
स्टोर द फर्स्ट इंस्ट्रक्शन. So when you store 50 bits, it will give you 6.25 bytes. So you will round that off to 7 bytes.
Okay.
Because the memory is in byte addressable type. So
Okay.
7 bytes. So when 100 instructions are stored, it will be 700 bytes. So you mentioned 5,000 bits, right?
Yeah.
But 7,000 bytes will give you how many? 5,600? 5,600 bits will be required because you cannot overlap. So you have to keep that in mind.
Okay.
You cannot just multiply it by 100 and then divide by 8, or you can say how this much bits will be required. Okay.
After so initially bits only.
Sorry?
Bits only we have to convert into bytes, right? Initially.
वो डिपेंड करता है, बट अगर बिट्स में भी करोगे आपका आंसर 5,000 था, बट वो आना चाहिए था 5,600.
5,600. Okay.
Because you cannot overlap 2 instructions in a same byte or block cell.
Okay. Okay. Okay.
After that, add M1 @R1 R2 R4. इसमें मतलब बहुत ही ज्यादा गलत था आपका आंसर. सो एड M, तो इसमें क्या है, पहला ऑपरेंड आपका पड़ा है R1 में, दूसरा पड़ा है R2 में, और उसको ऐड करके M में डालना है.
No, like this add MR1 will be separate and the R24 will be separate, right?
No, the instruction is add M1 comma @R1 R1 comma R2 bracket में 4. So this is how you read an instruction. So you have to put the last 2 operands in the memory. This is what this instruction means. So in the information fetch, you will fetch the data using 1 MR. After that, the instruction is 4 words. So you have only fetched 1 word right now. So you have to fetch in order to complete the instruction, you have to decode the 3 remaining words. Yeah, from memory to catch it. Okay. So for that, you will require 3 memory references.
Yes.
So that will be given by information decode. So 1 MR for information fetch, 3 MR for information decode.
Okay.
After that, first operand is @R1. So by using 1 register reference, you will get the data from register.
And that will be in memory.
The register will give you the effective address. And that effective address, you will go and fetch the data from the memory. So that will be 1 MR. So 1 RR plus 1 MR for fetching the first operand.
Okay.
After that, for second operand, first you will do 1 RR. You will get the value from R2. You will do 1 ALU operation in order to add 4 in that.
Okay. No, this 4 you said that indexing, right? This is not opcode, or not operand to add.
No, indexed जो एड्रेसिंग होता है उसमें यही होता है ना, आपको एक कांस्टेंट फील्ड दिया होगा.
यस सर.
तो कांस्टेंट फील्ड से आप उसको थोड़ा आगे जाओगे तो आपको मिल जाएगा. तो RR में मान लो 2000 डेटा है.
ओके.
2000 + 4 करोगे तो 2004 पे पहुंचोगे, फिर एक मेमोरी रेफरेंस करोगे तो आपको डेटा मिलेगा.
ओके.
So 1 RR, 1 ALU and 1 MR for the R2. Then in the ALU part, you will just perform ALU. You will add the data that you have got. After that, you have to store it in the memory. So 1 memory reference to store into the memory. तो देखो आपका इंटरव्यू DRDO का है, राइट?
यस सर.
सो देखो, अगर आप वहां पे कंप्यूटर आर्किटेक्चर को अपना फेवरेट सब्जेक्ट बोलते हो,
ओके,
थ्योरेटिकल में आपकी होल्ड बहुत स्ट्रांग है, बट जब उसको अप्लाई करने की बात आ रही है तो मैंने आपको जो सिंपल सा क्वेश्चन था 32 बिट सीपीयू 256 केबी मेमोरी, तो उसमें 32 बिट जो है वो वर्ड साइज है, बट जो सेल साइज है वो डिफाइन होता है 256 केबी से, तो
256
वहां पे
KB.
18 पिन आएंगे
Yes, sir.
एड्रेस लाइन, डेटा लाइन के, सॉरी सॉरी एड्रेस लाइन के,
Address line.
ठीक है। तो वो जो है कि अगर आपके पास थ्योरेटिकल नॉलेज है बट आप उसको अप्लाई नहीं कर पा रहे, और कंप्यूटर आर्किटेक्चर जो है बहुत ही टफ सब्जेक्ट है,
Okay.
तो उसमें अगर उसको आपको ग्रिल करना है तो वो आपको 2 घंटे भी ग्रिल कर सकता है, इतना इसमें वास्ट मटेरियल है आर्किटेक्चर में, बहुत ही कॉम्प्लेक्स सब्जेक्ट है।
Complex
तो
subject.
अगर
Yes,
आप
sir.
वहां पे कंप्यूटर आर्किटेक्चर अपने फेवरेट्स में बोल रहे हो तो आपको उसको बैक करना पड़ेगा, और न्यूमेरिकल्स मैंने जितने भी दिए हैं आपका एक भी सॉल्व नहीं, और वहां पे आपको वो बोर्ड पे खड़ा कर देगा कि सॉल्व दिस फॉर मी।
Okay, okay, okay,
So
okay.
if you are saying that this is your good subject or
Favorite.
you have a good hold on this subject, then you have to back it up.
Okay.
कंप्यूटर आर्किटेक्चर बहुत ही रिस्की यू नो
Subject.
सब्जेक्ट हो जाएगा, कि अगर बैक नहीं कर पाए तो बहुत ही नेगेटिव इंप्रेशन चला जाएगा।
Okay.
बिकॉज अगर आप उसको अच्छा सब्जेक्ट बोल रहे हो और फिर बैक नहीं कर पा रहे हो, तो वो आपके एक उस पे जाएगा कि अगर आप अपने अच्छे को बैक नहीं कर पा रहे हो, तो अगर वो कुछ सरप्राइज पूछ लेते आपसे तो उसका क्या करोगे आप? How will you able to tackle the problems there when you are not even able to answer the questions which I am asking from the subject that is your best subject.
Mm-hmm.
So बोल सकते हो कंप्यूटर आर्किटेक्चर, बट फिर बहुत ज्यादा इस पे रिवीजन की जरूरत है। बट एक्चुअली जैसे
Sure.
आपका थ्योरेटिकल नॉलेज इसमें ठीक है, होल्ड ठीक है आपका, तो ज्यादा टाइम नहीं लगेगा, 2-3 दिन दो इस सब्जेक्ट को तो हो जाएगा, न्यूमेरिकल्स भी आपका थोड़ा ग्रास्प हो जाएगा। न्यूमेरिकल्स भी
Okay,
ऐसे
sir.
नहीं कि न्यूमेरिकल्स ऐसा नहीं है कि आप सॉल्व नहीं कर पा रहे हो, इट्स जस्ट कि छोटी छोटी चीजें इसमें मैटर करती हैं। वर्ड साइज क्या है, एड्रेस साइज क्या है,
Address size. Okay, okay.
वो छोटी छोटी चीजें मैटर करती हैं। एक छोटे छोटे पॉइंट्स ही मिस करें आपने, ऐसा तो नहीं है कि बहुत ब्लंडर कर दिया है बहुत बड़ा, बट वो छोटे भी आंसर गलत हो जाता है। तो अगर उन छोटी मिस्टेक्स को रेक्टिफाई कर सकते हो देन गो फॉर इट, बहुत अच्छा सब्जेक्ट है, और बहुत ही यू नो एक वो भी होता है ना कि आपने टफ सब्जेक्ट खुद से चूज करा, तो दैट आल्सो सेज समथिंग अबाउट योर कैरेक्टर।
Something. Okay, okay.
तो ऐसा नहीं है कि सुसाइड है, कि मतलब अगर बैक कर सकते हो तो भाई बहुत बढ़िया, कंप्यूटर आर्किटेक्चर बहुत कम लोग बोलते हैं।
Okay, sir.
ठीक है, सो ऑल द बेस्ट, राइट?
Thank you, thank you.